Okay, just bear with me. We're going to go through this PowerPoint in its entirety all together, but we're just working with our little mini lesson. So the last mini lesson we worked on was our special triangle. So we're going to recall our triangle stuff now. So when we had a 45-degree triangle, I showed you that one. And I said, well, now let's make sure that this side, it's the same 45-degree triangle. We want to have the radius to be 1 because a unit circle has a radius 1. So where here we had square root of 2, to fit in the unit circle, the radius, which is the hypotenuse size, must be 1. So we applied all of our values that we found in our little mini lesson, and we see that that's how that triangle fits in. Now the x value of this guy would be square root of 2 over 2. You're going to learn these in just a minute. I'm going to give you these definitions, but we're just talking about these triangles. It's going to be your y value is this because it's the height. Square root of 2 goes in the ordered pair. This is your x, this is your y. And then the x value will be that case. So we can see as we go around the unit circle, we can fill in these triangles and so that they fit, and we can find the x, y values at particular locations. Just to show you the last triangle that we worked on was another 30, 60, 90 triangle. It was a special triangle as well. We originally started with these values, but now we're going to require our triangle to have a radius of 1 so that it fits the unit circle. So to do that, we're going to have to create a similar triangle with a radius 1, and so that means divide everything by 2. So when we divided all the sides by 2, it was here because the 30 degrees was there. We're going to teach you some of these definitions in a minute, and you'll see how this all comes together. So the y value is the 1/2, and the x value on the x squared is the square root of 3 over 2. So these triangles are just located all the way around this unit circle, and that's how we find all those values in the end. We're going to see one more. This time it's the 30, 60, 90, but we can see we're going to work with the 60-degree triangle and see how it fits in, just so you see another example. Remember, for the unit circle, it has to have a radius of 1, so that's the biggest concept that we're had to do that mini lesson for. So our values are now this. So in our ordered pair, this is the x value, this is a y value, so your x is always this value and your y is this one, so it's like your height. You're going to learn that this is the cosine and this is the sine, and then when you plug them in, this is your y value, this is your x value, which you will learn them by definition as your sine and your cosine. That is going to help us create our values in our quadrants. Okay, so we're going to stop now and go back to our breaking these things down into smaller mini lessons. Okay, so we're going to define our unit circle as a circle whose center is the origin, which is 0, 0, with a radius of 1. Recalling from college algebra, equation of a circle is x squared plus y squared equals the radius squared, but because the radius is a known 1 here, this is our equation of a unit circle. Now I'm going to draw a figure in just a second so we can extend this a bit. Okay, so here's our little picture we're going to work with. So I'm going to give you some definitions of our 6 trig functions, but they're going to come from this idea right here. Here's my circle, radius of 1, so from 0, 0 to here is 1 unit. That would represent that. This is my x-axis. This is my y-axis. I drew an angle in here, and the angle measure is t. Remember, your s is your arc length from the previous lesson, and arc length was defined by that formula. Now, on the unit circle, the central angle measure in radians is equal to the length of the intercepted arc. So with that in mind, we'll say S is equal to, what's the radius in this one? 1. Okay, and in this case, what is our angle? What's our angle called? Just t. So 1 times t. Well, what's 1 times t? So all it's saying is S is equal to t. Okay, so this is why our trig functions are going to be defined with this next page with the definitions on them. Okay, so we have our definitions of our 6 trig functions. Sine of t equals y, cosine of t equals x, tangent of t equals the y over x. This x cannot equal 0 is because we cannot have 0 in the denominator. Now, I specifically wrote them this way because I want you to see cosecant is the reciprocal of this guy, right? So if this is y over 1, the reciprocal is 1 over y. X over 1, 1 over x. Y over x, x over y. So sine of t and cosecant t, they're reciprocal functions of one another, as well as these two are reciprocals, and then tangent and cotangent. So that helps when you memorize, because if you memorize this side, then you can use that to help you figure out the other trig functions. Now, I want to just make sure that you understand this. If theta is t radians, then all of our definitions take this form, which I didn't finish out all 6 of them, but you will see where if theta is equal to t, everywhere there's a t in our last one, we just simply plug in theta. Sine of theta equals y, cosine of theta equals x, tangent of theta equals, which I started to do here and just stopped because it's just redundant. But don't let that confuse you. Sine of t or cosine of theta, both have the same exact definitions, are defined in the same way. Okay, at this point we're going to stop the video and we're going to go to our unit circle PowerPoint and practice the unit circle in its entirety before we move into the next video, which will be some homework examples for section 2.2. Not